So predictive maintenance is the process of estimating component degradation and remaining useful life. So this can be done one of two ways, either through gathering large data sets and training algorithms to detect failures, or we could use physics-informed machine learning, which combines physics-based models and machine learning to identify parameters that indicate component degradation that would otherwise be invisible to operators. So a good example would be, say, a motor or a pump. If the bearing was starting to wear, you would see that rationalized as essentially increased friction. Now, friction coefficient is normally fixed, so if you could develop a model that could essentially observe that, you can see if it starts to change, likely increase, you could rationalize that as the degradation of the component, i.e. the bearing is starting to fall apart. And from there you could then use that to inform when you're going to do your maintenance work or corrective work. And similarly, you can also forward project, so looking at the data trend of how that friction coefficient is increasing, you could make a reasonable, well-informed prediction as to when it might actually fail, so you know exactly at what point you would need to make a decision around when to pull it out of service and repair and fix it, etc. So these trends being extrapolated forwards in time to estimate remaining useful life can help improve companies away from sort of this reactive maintenance zone into and sort of even overly cautious preventative maintenance to a more data-driven, proactive maintenance strategy, which is timed based on insights rather than arbitrary time periods or usage.